All right, let's get into it. Today we're taking a deep dive under the hood of what might just be the future of gaming, AMD's brand new RDNA 4 architecture. Now, we've poured through their technical presentation so you don't have to, and we're going to pull out all the key innovations that are really going to power the games of tomorrow. Let's do this.
Okay, let's just jump right to the jaw-dropping numbers, shall we? This chart shows the performance boost you get per compute unit compared to the last generation. And honestly, the results are kind of wild. We're talking 2.5 times faster in regular old rasterization, 3.5 times in ray tracing, and a staggering 4.5 times jump for AI stuff. That is a massive, massive leap in efficiency, which, of course, begs the question, how in the world did they pull that off?
Well, you see, gains like that don't just happen by accident. It all starts with having a super clear focus. AMD's architects basically went back to the drawing board with a very specific vision in mind for RDNA 4. They were really thinking about what a gaming engine truly needs to thrive for the next 5 years.
And here it is, that vision, spelled out plain and simple. Their goal wasn't just to make a chip that does a little bit of everything okay. No, it was to build an architecture built for gaming. This one idea, this is the North Star for every single decision and every feature we're about to talk about.
So, what does that built-for-gaming mission actually look like in practice? Well, here's the game plan. We're going to start with that huge leap in ray tracing. Then, we'll dive into the new AI capabilities. After that, we'll hit on the core rendering and efficiency upgrades, and we'll finish up with some really big improvements for all you streamers and creators out there.
First up, let's tackle what might be the single biggest story here, ray tracing. For years, this has been an area where AMD has been seen as playing a bit of catch-up. Well, with RDNA 4, it looks like they've made some incredibly clever changes to how the hardware itself handles light and shadow. So let's dig in.
Okay, so one of the star players in this new system is a technique called oriented bounding boxes, or OBBs. Just think of it like this. Older GPUs would put game objects into these big, clunky, one-size-fits-all shipping containers. OBBs, on the other hand, are like perfectly tailored, custom-made packaging that fits the object absolutely snugly. And that perfect fit makes it way, way easier and faster for the GPU to find what it's looking for.
In this slide, it's the perfect visual for that difference. On the left, you see the old way. A ray of light has to check this big, awkward box that's mostly just empty space. That's a false positive, a totally wasted bit of work. But on the right, with OBBs, that box is super tight. The ray hits it and immediately knows it's found something real. The engineers actually call this a cooler heat map, which is just a great way of saying the GPU isn't burning energy on pointless work anymore. So what's the actual reward for this clever new packaging idea? On average, you're looking at about a 10% performance improvement in ray tracing just from this one innovation. That is a seriously big deal from a single, really smart architectural change.
Now, the next big trick up their sleeve is something called out-of-order memory. The absolute best way to think about this is like an express lane at the supermarket. Before, if a really quick data request got stuck in line behind a really slow one, well, too bad, it just had to wait. Now the GPU can zip those quick jobs into their own express lane, completely bypassing the traffic jam. The end result is just a huge reduction in waiting time, keeping the whole pipeline flowing nice and smooth.
So you take all these clever improvements, the tighter bounding boxes, that new memory express lane, and a few other tweaks, and what do you get? What's the final payoff? You get this, a 2 times increase in raw ray traversal performance compared to RDNA 3. That's not just an improvement, that's the kind of jump that truly changes what's possible in games.
All right, on to our next major pillar, artificial intelligence. AI isn't some buzzword in graphics anymore. It's become a fundamental tool. It's powering everything from smart upscaling that gives you more frames to making in-game characters act more realistically.
And just look at this performance jump. This chart shows the peak AI calculation rate, and RDNA 4, using this new trick called structured sparsity, delivers a 4 times increase over RDNA 3. That's not just better, that's a whole different league. This is the kind of raw horsepower you need for that next wave of AI-driven gaming.
So what does all this new AI muscle actually do for you, the gamer? Well, for starters, the hardware is just way more efficient. That sparsity feature basically lets the GPU skip doing pointless math, which instantly boosts performance. But the real big-ticket item here is that this lays the groundwork for way, way better super resolution. The tech that lets your game run at a lower resolution for high performance, then intelligently scales it up to look super sharp and clean.
Of course, these days, gaming is about so much more than just playing, right? It's about streaming, it's about creating content. So for all you creators out there watching, listen up, because AMD has built in some major upgrades to their media engine just for you.
RDNA 4 has this new dual media engine, and what that means in the real world is you can stream with up to 25% better quality using the same internet speed. Your video renders will finish way faster, with double the speed for the new AV1 format. Oh, and you'll be all set for those next-gen monitors with full support for DisplayPort 2.1a and HDMI 2.1b.
Okay, so we've seen all these amazing features, but how is the chip itself actually put together? Let's take a quick look under the hood at the system on a chip, or SoC design, that really makes all of this possible.
At its very heart, RDNA 4 is a modular design. The best way to picture it is like a box of high-tech Lego bricks. AMD has basically created this perfect blueprint of compute units, memory controllers, and media engines that can all be arranged and scaled to create all sorts of different products.
And this approach is just so smart. It's modular, it's secure, and it's resilient. It lets AMD be incredibly efficient. So instead of having to design dozens of unique chips from scratch, they can just use this single, scalable blueprint to build a whole family of GPUs, from the most powerful monsters down to the most efficient little chips.
And that, my friends, leads us to the payoff. Let's see how all this incredible technology and the super smart design philosophy actually translates into the products that are going to be powering our gaming rigs.
And here we go, starting with the big guns, the high-end 9070 series. The flagship XT model is the absolute beast of the lineup, rocking 64 of those powerful new compute units and 16 gigs of memory. This is the card for gamers who want to just crank everything to max at 4K, with all those new ray tracing and AI features running at full blast.
And this is where that whole Lego brick design really starts to shine for the mainstream market. With the 9060 series, you can actually see AMD scaling that same core architecture down. They can create a card with fewer compute units to hit a lower price, or they can offer two different versions of the XT, one with 16 gigs of memory for future-proofing, and another with 8 gigs to hit a really aggressive price point. It is all about giving you options.
So, when you boil it all down, what's the big takeaway here? RDNA 4 isn't just one single thing. It's a combination of these revolutionary leaps in ray tracing and AI, paired with smart, practical upgrades for streamers. And it's all built on this incredibly flexible foundation that lets all these amazing technologies scale from the highest-end cards all the way down to hardware for every single gamer.
And that leaves us with one final and pretty exciting thought. We've seen what the hardware can do. We've seen these incredible leaps in performance and capability. The question now is, with tools this powerful, with AI and ray tracing that can render worlds with this much realism, what kind of absolutely incredible new games and experiences will developers create for us next? I, for one, cannot wait to find out. Thanks for listening.